In the previous video, we had a dog class and a cat class that both inherit from an animal class. And this was cool because, first of all, it allowed us to reduce repeated code, but also it allows us to store dog and cat objects together in the same collection. But unfortunately, it also allows us to store animal objects along with them. And this might not be what we want. So for example, dog and cat are both more specific than animal. And if we wanted to be able to represent kind of any old animal that could be represented just by like a string type, we could just use an animal class on its own. We wouldn't even need dog and cat. But so how do we prevent ourselves from using an animal object rather than the proper dog or cat object? We can do that using an abstract class. So if we come up to here to the definition of the animal class and we add the word abstract to the front, animal is now an abstract class. So what that means is that we can't instantiate the class anymore. We can't do this, and that's why we've got an error here. We can instantiate dog, the dog class. We can create dog objects, even though the dog class inherits from animal, but we can't directly instantiate an animal object. We can't create an animal object directly. So we can change this to cat though. And if we run this, we can see we get some output here. Now, we've still got this animal sound here next to cat. And that's because in the abstract class animal, we are creating the method speak so that we can use it for either a dog or a cat. But then in the cat class, we haven't yet overridden it. We haven't created a function to replace it. And so this isn't really ideal. We also want to kind of force ourselves to not use this function. We don't ever want this behavior. And we can do that as well by using what's called an abstract method. And we can only use abstract methods on abstract classes. So let's remove this. Let's put a semicolon at the end and add the word abstract into here. So we've got public abstract void speak. And the animal class is now fine. The dog class is also fine. But the cat class is throwing an error. The type cat must implement the inherited abstract method animal.speak. And so this is giving us an error because we've inherited an abstract method. So we've got the class cat, which is not abstract, that has an abstract method because of inheritance. Just quickly, if we were to make this an abstract class, if we have an abstract class cat, we lose the error. We don't have the error anymore because now we have an abstract method because we haven't replaced it yet, but it's on an abstract class, so that's okay. But this does mean that we can't instantiate cat because now it's an abstract class. If we take this out, we can also uncomment this and we can see that all of the errors should go away. So now that we've overridden the abstract class, as far as the cat class is concerned, we don't have any abstract methods, and that's what we want because we don't have an abstract class. And now we should have the proper behavior. If we have more objects that inherit from animal than just a dog and a cat, maybe we have now a bird, there may be certain characteristics or methods that we want to be able to share between some but not all of the animals. So for example, maybe a dog and a cat can walk, but a bird can't. That's not necessarily true to reality. I think birds can, at least some birds can walk, but maybe we want to only have a walk method for dog and for cat. Well, how can we do this? One thing that we could do is we can say we have another abstract class under animal that is going to be a walking animal. And under walking animal, we can indent dog and cat. So dog and cat are no longer going to inherit from animal, they're going to inherit from walking animal, which itself inherits from animal. Now, walking animal can have the walk method, so dog and cat can share that method. But now, what if we have a situation where the bird and the dog share a different characteristic that the cat does not have? Well, now we've run into an issue, because inheritance works like a tree data structure. If you want to learn more about tree data structures, I have a video on my channel that I'll link below. But essentially, we've got this hierarchical structure. We've got animal at the top, and we can't have multiple overlapping sets. We can't have a collection with a bird and a dog, as well as a connection with a dog and a cat that don't overlap. So we've run into an issue. And one thing that we could use in this situation, and in fact we could get rid of this walking animal entirely, and we could use an interface in order to share a method between two specific objects. So an interface allows us to kind of ignore the hierarchical structure of inheritance. So let's create an interface called CanWalk. Now, especially if you're working with C#, you may see interfaces prefixed with I. So this is interface CanWalk, and this helps us distinguish just from the name whether it's an interface or a class, whether it's a normal class or an abstract class. We can differentiate an interface from a class. I've also seen this used in Java. I don't think it's as common, but let's stick with it for now. So we've got interface CanWalk. And what we're going to have in here is we're going to have a public method. Going to be abstract. We don't want to define the code inside of it. We want to return nothing, and we want to call it walk. We're going to have a semicolon at the end. So we've got an abstract method inside of here. Now, interfaces cannot have definitions. So we can't have a non-abstract method inside of an interface. Abstract methods do not specify a body. And so this abstract keyword, when you're inside of an interface, is optional, and it's usually omitted because we don't need to include it. If the method is inside of an interface, it must be abstract. Okay, so now we can come down to the dog class, and we can, as well as extending animal, we can also implement the interface CanWalk. Now we're going to get a familiar error. The type dog must implement the inherited abstract method interface CanWalk.walk. So we need to have a method here at override public void walk. And maybe we're just going to have dog is walking. And that's allowed. Now, if we have a collection of animals and we loop through them, and we want to be able to see whether an object has implemented an interface or not, we can do this in the exact same way that we would with an abstract class, with inheritance. We can say if pet instance of, and we need to use the interface name, so interface CanWalk, and then we would do the exact same thing as we had with inheritance. We would use interface can walk and maybe walking pet, and we have to convert pet to the I can walk type, and then we can do walking pet dot walk. And if we run this, we get Benji, woof, dog is walking because Benji is a dog, and then we get cat, meow, and then we don't get anything underneath here. Interfaces and abstract classes kind of have similar purposes. There are a few important distinctions to keep in mind. The first is that interfaces cannot give definitions of methods. We've got a method declaration here, and that means that any class that implements this interface must provide a definition for this method as we've got here. An abstract class, on the other hand, is just like a normal class, but it can't be instantiated. So this means that we can give our own definitions, but we don't have to. And either way, we can override the methods in the subclasses. So dog extends animal. We can, if we want, override this method birthday, public void birthday. And that would be absolutely fine. Even though we've got this definition here, we can replace it. But if we have an abstract method, then we need to provide a definition for that. A class can also implement as many methods as we want. So if we had another interface here, let's call it iTest. We can add a comma here, implements I can walk and iTest. Now, we don't have any abstract methods inside of iTest, so we don't need to do anything, but this kind of showcases that we can have as many interfaces as we want, whereas we can only have one abstract class. With classes and inheritance, we can inherit from only one parent, so we can't extend multiple different classes. We can't extend from multiple different abstract classes either. We also can't inherit from a normal class and an abstract class. There's only one. Whereas interfaces, because they're a bit more, they don't have the hierarchical structure, so we can implement as many as we want. Interfaces also don't allow us to have dynamic properties, so we can't have something like int age. Int age wouldn't be allowed because an age is something that is dependent on the object rather than the same throughout the whole class. We need to have static properties, and properties must also be constant or final, which means that their values can't change. So we would need to do something like int age equals 5, and then that's okay. But then the age wouldn't make sense. So most of the time, you're probably going to want abstract classes instead of interfaces. Interfaces are a bit more flexible in that we're allowed to link different otherwise unrelated objects together with something that they can do. But an abstract class allows us to share properties and method definitions. So that's been interfaces and abstract classes. In the next video, we're going to be talking about encapsulation and abstraction.